Hello and welcome to yet another of the series of the interesting conversations with people from software development. I'm Alex Bolboaca. I'm coming to you from the Mozaic Works studios, and my guest today is somebody who is focusing on the intersection of product development, strategy, architecture, leadership, and software engineering culture. I am fascinated by intersections between domains, and I started reading his PhD thesis today, and it's completely fascinating to me. So, welcome, Ken Power.
Hey, Alex. Thank you. Great to be here.
Before we go into the details of uh, all these things that you are interested in and we share an interest in, I find it very useful and interesting for the audience for my guests to tell the story of how they got into software development. What brought you here? How did you start programming, or why did you get
Okay.
into this domain?
Oh, wow. Okay. So, wow, a very non-linear journey, I would say. So let me see. My first programming experience, I had a VIC-20, a Commodore VIC-20 when I was a kid, and then upgraded to a Commodore 64. So what age would I have been? Probably around 12 years old, something like that. Started programming games in Commodore Basic, so that was my first experience of programming. I didn't know there was a programming industry outside of that, but I was lucky enough to have a computer and be able to experiment with playing and doing things with it. And when I went to high school, or what we call secondary school, luckily there was some computers there as well, and we had very limited access to them, but we were able to experiment with them and program them. I think there was DEC machines, DEC machines, the old digital equipment machines. So this was back in the late 1980s, which is quite a while ago. So when I finished high school or secondary school, I didn't really know what I wanted to do with my life. So being 17 years old, didn't really know, but I knew I enjoyed computers and I also enjoyed music. And I thought, well, I could do something that combines those and work on things like digital effects processors were a thing at the time for guitars and musical instruments. So I decided to study electronic engineering, so I could work on those. So my projects during that course of education tend to be centered on building stuff for music and for music processing, and that was really interesting. And it was through that diploma in electronic engineering that I discovered things like Pascal and C and software engineering and assembler language, and it really exposed us to a wide variety of technologies that I didn't know existed before that. And from there, I decided, well, I really like this software stuff. It's fun to, yeah. I always liked the intersection of software and hardware and people and the environment around those things, and software engineering seemed like a good way to expand on that. So I went from a diploma in electronic engineering to doing a degree in software engineering. And yeah, that sort of set my career on a path of going deep into software engineering. And so this was the mid '90s then, when I did this. And my first job as a software engineer was working for a company called Hella in Germany. And I was working on car security systems for automotive groups like BMW and Volkswagen, and that exposed me to things like software engineering for big systems and small systems, because we were doing a lot of embedded development, but with a wide range of applications. And that was a lot of fun. So working on those sorts of systems was great. From there, I worked in a number of domains then over the last 20 years: travel technology, distribution systems, finance systems, and for probably about half of my career, I've been working in some variety of networking systems, so networks and telecommunications. I spent about 11 years with Cisco, where I worked on unified communication systems, network function virtualization, network routing systems, all sorts of areas. So that's a long answer to how I got into it, but I feel like I'm still learning and exploring in this space. And more recently, in the last few years, I've been getting really into software engineering for AI systems and deep learning systems. Again, going back to the automotive sector, which is where my passion is right now, on the application of all of this stuff I've learned first around software engineering and software architecture. There's been as you're well aware, there's been a real growth and explosion really in what we can do with deep learning technologies over the last few years. So I'm sure we'll get into some of these things, but my current focus is taking all of this stuff on software engineering and software architecture and applying it in the context of deep learning systems and intelligent autonomous systems and self-driving cars and those sorts of technology areas. So it feels like I'm still in a bit of a toy store, really, with the opportunities that this sort of technology provides.
So I think you are in a particularly interesting position, since you've seen and worked with various types of engineers during your work. Right. Because I believe in software we have a kind of identity crisis. We keep wondering, is software engineering, is software a craft, is software design, is it something else? Should it be more industrial? Should it be more like crafted? And so on. And I'd like to ask you this question related to software engineering. Is software engineering a proper name when you compare to other domains, or what do you think?
Oh gosh. So right. So yes, and so well, the key word I'm going to pick up on there and what you said is identity. And I think as an identity, the term software engineer, regardless of somebody's background or formal education or how they came to be in this field, I think the term software engineer for me is an interesting identity that speaks to creativity and problem solving and making the world a better place through technology and collaborating with lots of people on a grand scale to achieve things that we couldn't achieve on our own. So I love the debates on software engineer versus developer. Is it an art? Is it a craft? A science? An engineering discipline? And those, I'm very happy to go as deep as you want on those distinctions. But the short answer to your question is I identify with the label of software engineering and find it useful.
Okay, so I've been thinking a lot about this topic and actually looking at how engineering has evolved in time and looking at the differences from science and so on. And I just want to throw some ideas and just trying to figure out what you think about those and trying together to figure out what they mean. So on one hand, I believe that one particularity of engineering in general is that it's more empirical than it is scientific, in the sense that as an engineer, my primary goal is for the current object that I'm building to be sound. I don't necessarily look for all the laws that make every such construction to work, right?
Yeah.
And in order to do so, I need to go through a trial and error kind of cycle, through experiments, trying out things, seeing what works, seeing what doesn't. And in time, these techniques improve. And I get to a point where I can say, now we have a stronger basis, we have a kind of science. And to me, it feels like we are still in the beginning of this process for software.
Yeah. Oh, I agree completely. And yeah, as a profession, Margaret Hamilton is credited with coining the term software engineering back in the 60s as part of the Apollo program. But when we think about it, the 1960s was before we were born, but it's still so recent in terms of the history of our profession. It is software engineering is a young profession compared to other professions such as medicine or law that have, in some cases, thousands of years of learned wisdom and foundational principles. And that's not to say that's not to say that we're an immature discipline. Some cases maybe we're still learning and growing, absolutely. And if we talk about what are some of the fundamental principles of our domain of software engineering, for me, a commitment to continually learning and growing is right up there as one of the top ones. But then there are more direct principles like paying attention to things like coupling and cohesion in our systems design is as important now as it was 30, 40 years ago, 50 years ago. So there are some principles like that while the systems we're working in may be growing and getting more complex and incorporating new technologies, some foundation principles such as coupling and cohesion and paying attention to the cyclomatic complexity of your dependencies in your architecture. These are things that are helpful to do regardless of what sort of domain you're working in. Now, another point. Yeah, sorry, Alex. Yeah, go ahead.
Yeah, and I'm thinking that you mentioned some of the things that I'm looking at and that I associate with engineering, which is looking at some metrics related to your code, even if those are local or if those are, they need interpretation. It's never a metric that works everywhere. And
exactly.
And measuring various things, trying to improve them, looking at characteristics such as coupling and cohesion, knowing about those first and then applying them, right?
Yeah, absolutely. And you mentioned measurements there. An important aspect of measurement in this space for me is what measures am I consciously deciding to apply to my work so that I can introspect about my work and make it better, which is a different perspective than saying, well, what metrics am I going to apply to you and your work so I can evaluate your work? So how we use metrics is important in software engineering. And sometimes we can get lost with applying too many metrics to other people's work instead of using metrics for introspecting and improving on our own work.
I think this is part of what I think as an engineering mindset, which is thinking about how you solved problems or how you work towards solving problems and trying to extract some practices that you can repeat, that you can apply again and again and that work for you, that don't necessarily work for everybody, but that work for you. And sometimes those get generalized to maybe not everybody, but more people, right?
Yeah. Well, absolutely. And for me, part of the work of an architect, part of the responsibility of architects is to look at systems holistically, sociotechnical systems holistically, and understand, well, what are the implications for the technologies we're adopting, the structures of the system, how we're approaching building the system, how we're organized around how we build the system, how our system makes money. All of those sorts of things are for me part of the spectrum of responsibility of an architect. But what your previous point, you're touching on things like the processes we use to build our systems, and very often we can become, as an industry, we can become over enamored sometimes with processes for process sake, and not put in place systems where people are in control of their own processes. What works best for you on any given day may not work best for me, and vice versa. And how we build systems, I think, needs to account for that. Some things we need some standardization on, absolutely, but there are other things where we need degrees of freedom in how we build systems.
Yeah, and I was discussing with people who are building hardware for a while, and and then they became programmers, and they were telling me that it was a very similar process. So it's not like in civil engineering where you go and design everything and then you go and build and you can measure, because there you have the laws of physics that help you and that are relatively well known. But very often, even in electrical engineering, it's a lot of trial and error, a lot of let's try, let's see if this works, and so on. And then after a while, you get to standardize, you get to produce something that can be reproduced. Or
there is a time in the life cycle of systems where we need to commit to a decision, and there are times where we can afford to experiment. And absolutely, one thing Rebecca and I talk about in some of our workshops is this idea of the most responsible moment to make decisions as opposed to the last responsible moment. Sometimes the last responsible moment for some people can be a little nervy or a little too late in some cases, and particularly when you're dealing with integration of multiple subcomponents or multiple subsystems, and if some of those systems are hardware systems or FPGA or firmware systems, they have different constraints than a purely software-based system, and we have to respect those constraints. I've worked a lot in such systems, hardware, software, embedded systems, and co-development of hardware and software and firmware and so on. And there are absolutely strategies for managing those different constraints. But sometimes we run into problems or integration issues if we assume too much about what those constraints or dependencies are.
And I think this brings us to what are some of the ideas that show a lot of promise, at least from my perspective, to defining these fundamentals, these strong fundamentals for software engineering. And I think one of them is the whole theory around complex adaptive systems and Cynefin and so on, which gives us a model for organizing. And another one that I've been looking at is focusing on the fact that we are working with knowledge. And I think that this is not discussed enough and not stressed enough. And you've done quite a bit of work into this idea of flow development and complex adaptive systems and so on. So can you give a summary of what you've tried to do with your PhD thesis?
Yeah, absolutely. So first of all, thank you for reading it. It's always great to hear somebody has read it. So I did a PhD comparatively late. I didn't go from my bachelor's degree straight to a PhD. So I worked in industry for many years, and I did my PhD part-time while still working full-time in industry. And so it took me about 7 years or so, overall to complete that. But what I wanted to do is sort of go back to first principles of understanding how organizations work. Because throughout the course of my career, I tried to pay attention to not just the technology that we use in building systems, but what are some of the challenges we have in building systems, and very often those are people-related challenges, and by that I don't mean people are the problem. I mean the systems of work within which people operate are very often the challenge, and how we're organized around doing the work. Despite our best intentions, we can make decisions for how we organize around doing the work that don't work out well. And part of the reason for that I observed was we often try and over standardize how we approach building systems. Back to the point on assumptions and constraints. We often make plans around how we're going to build systems and get frustrated if those plans don't start to work out, and we put a lot of effort into getting back on track with our plan instead of realizing, well, maybe what we need here is a more adaptive approach to how we're building systems. And that's not to say we don't plan at all. It's to get to the point that sometimes we're building systems in spaces where things are neat and predictable, and there is an obvious connection between cause and effect, and we've built similar systems or similar subsystems many times before. It's familiar territory. nothing much is changing in the technology space. We still have the difficult job of understanding what our system needs to do and engage with our customers and our users and our other stakeholders and build a system that meets people's needs. That's all. That's all still part of the equation. But there's a lot in the technology and the product space that's relatively stable and predictable. We can chart a path from where we are to where we need to be. Then there are other times where things are not so stable. Things are changing quite dynamically. Maybe we're working with technology that's still emerging, that's still even being invented in some cases. Maybe we're in a market space or a domain space that's rapidly evolving, and that itself is very unstable and unpredictable. And what we planned for a month ago, some of the assumptions we made no longer hold true. So these sorts of things were really interesting to me when I started to explore the idea of doing a PhD, and I started to look at organizations in multiple domains that had a good track record of building products under conditions of uncertainty in big spaces. And one of those companies was Toyota. I was really interested in the work of Taiichi Ohno, who's credited for inventing the Toyota production system, and his approach and philosophy to enabling and empowering people to be in control of their own work environment and make not just the product better, but make the work environment better so that we can have better outcomes. I was also interested in the work of people like Deming and early work in things like lean product development and lean thinking, and other work that led me to look at things like flow as a concept that originates in things like the Toyota production system. So combine that with work I'd been doing in agile development and lean product development and software engineering. I wanted to see, well, how can I bring all of these things together? So, around about 2010 or so, I started to become more aware of things like complexity theory and complex adaptive systems. I discovered things like Glenda O. Yang's work on human systems dynamics, Dave Snowden's work on the Cynefin framework, and a whole host of other stuff from the Santa Fe Institute and various other sources that I started trying to integrate and understand, well, how can I make this apply to the work that I'm doing in the context of product and system development? And one of the big realizations or learnings that I had was, well, people, organizations, teams are complex adaptive systems. We have properties that are emergent. We have nonlinear outcomes. We have not always obvious cause and effect relationships. We have, we have patterns of behavior that are identifiable. All of these things started to make sense. And the more I dug into this space, I came across work by people like Vike on Sensemaking, and all of this stuff really became kind of the foundation that I started to build on for the PhD research. So for the PhD then, I developed a framework for looking at organizations through this lens of complex adaptive systems to understand, well, how are we working in these large scale, my area of work is in large scale product and systems development, so I decided to focus on that. How do we get stuff done in large scale product and system engineering efforts? What are the things that help work to flow more smoothly through these systems? What are the things that impede or inhibit stuff happening in these systems? So that was the foundational set of questions I had for understanding how do these things apply. And I'm happy to go into more detail on some of these things. Like you mentioned Cynefin, we can talk about those things, whatever makes sense.
I think one interesting challenge that we see when I try to explain and use these Cynefin and complex adaptive systems with various organizations is figuring out how to do sense making, particularly in large organizations, sometimes in organizations that are distributed and so on. And I know that you have some ideas around this in your PhD.
Right. Yeah, so I suppose first thing I'd say about sense making is it is an approach or a set of tools and practices for understanding complex adaptive systems. So on one side we have these complex adaptive systems like organizations or cultures or teams or other things or ecosystems. And then we need some way of understanding, well, what is happening in these complex adaptive systems. So that's where sense making for me comes in. It's a set of approaches for trying to make sense of or understand the patterns in a complex system, so that we can get stuff done, so that we can influence change. And then Cynefin, as you mentioned, is a sense making framework to help us look at and explore complex systems. So all of the work that I did in the scope of the PhD and beyond elsewhere is in the context of these large globally distributed organizations. So there's a couple of aspects to it. One is the sense making framework itself. So I'll generally start by designing a sense making framework, which is basically a set of questions. It's not a survey exactly, but it's a set of questions to help us explore the system that we're talking about. And it's generally consists of, well, so there's an approach that I like to sense making that the Cynefin framework and Carl Weick and other sources use. It's called narrative sense making. It's basically trying to understand a complex system through understanding the lived experiences of people in the system. So we don't set out with, there isn't the equivalent of a thermometer or an oscilloscope that we can plug into our organizations and try and understand, well, what's the temperature today, and get an exact objective reading. So we need these approaches that help us explore systems, reveal the patterns that are at play in our systems, and narrative sense making is one such approach. So it starts with getting people to articulate some experiences that they're having in the organization, and it really is as simple as that. Usually through words, but it could also be through images, or I like to use metaphors sometimes. I would like to also use pictures. But the point is so if I was doing this with you, well, we wouldn't do it just one-to-one, we'd do it with a large group. But if you were part of that group, I would be asking you, here's a situation, tell me an experience that relates to that situation, an actual experience, not a hypothetical one, your experience. And then I would have you answer some questions related to that experience that might reveal some things about the patterns that are at play in your system, in your architecture, in your organization. And the important point here, or one of the important points here, is through that process of answering questions about your experience, you are telling me how significant that experience is to you. I don't have to interpret the significance of the experience. I don't have to make judgments about, was this a good experience or a bad experience, or what did it mean, because the framework is designed for you and dozens or hundreds of other people to contribute those experiences and the significance of those experiences. So once we collect those, we stand back together as a group and we look at the patterns that have emerged. And there's a couple of things here worth pointing out. One is this cycle that I'm talking about, from capturing experiences to answering questions about your experiences, to us then collectively stepping back and looking at the patterns. That usually takes about a couple of hours. So we're not talking about a process that takes days, weeks, or months. This is a very fast feedback cycle that I like to use, where we can start to get insights and take some action pretty quickly. So in this process, we're looking for patterns of behavior, patterns of things that are happening within our organization or within our architecture that might be of interest to us. And there's a few ways to do this. One is, I would usually do this if we were in person. I would usually do this with posters in a room. With distributed organizations, I would use some sort of online tooling support and have people work with that. I'll expand on all of this in a moment, but just to get the basic process, it's identify the narrative, capture the narrative, answer some questions related to that narrative, and then look at the combined patterns that are emerging from those experiences that we're collectively having in our organization. And the last thing I'll say in relation to this, just for the moment, is for me, sense making is a collective process of problem solving and pattern identification in organizations. It's not somebody coming in to your team, your organization, to tell you what your problems are. It's a process where we collectively take responsibility for identifying the patterns in our organization, for identifying what are the challenges or the opportunities we want to address, and then making some decisions together to take responsibility for changing something in those patterns so that it leads to the outcomes that we want to have. And I'll pause there because that's a lot on sense making.
I find it fascinating because it sounds like a combination between anthropological studies and semiotics. It's kind of figuring out what the symbols are in the and what the meaning of symbols are in the organization.
That's exactly right. So semiotics, you mentioned right there, and there's a famous philosopher in that field, Charles Peirce, who did a lot of the foundational work in semiotics. His work has been very influential in the field of sense making, and Weick in particular acknowledges a lot of that. And anthropology, absolutely. I mean, we're dealing with human systems, and trying to understand behavior and other factors in human systems. It's fascinating. I use the term sociotechnical systems a lot for that very reason. My personal outlook on this is it's difficult to separate the human element of the systems we build from the technology elements. There is a constant interplay between the two. And I think these techniques that you mentioned, like anthropology and semiotics and sense making and other things, are probably not traditional tools in software engineering, but they're very useful tools in software engineering.
Well, yeah, I mean, I understand why people would believe, and even many programmers would believe that, we are a very technical domain, but whenever you have large groups of people, you already have anthropological effects coming into place. And whenever I have a team that is more open to conversation, I like to tell them that, the Scrum Master is fundamentally the follower in history, in anthropological terms, of what used to be like the old mages from tribes, because their primary role was to preserve the memory of the tribe, and that's what the Scrum Master is supposed to do as well. Only the tribe is now a team or a squad or however you call it, and but it's the same fundamental idea. And sometimes I see weird looks, but it's what it is. It is the nature of human organizations, right?
Right. Yeah. No, I get what you mean there, and I mean, you touch on a really important point about the oral history of teams and organizations. So much of what's important to know about a team and an organization and how we work is not written down anywhere. So if you think about joining a new team and what their onboarding process is, a lot of that sometimes involves just going for coffee and having a conversation about how things are done around here, as opposed to the formal HR manuals and things. And I find that comes into play for me in things like software engineering and software architecture as well. The sense making stuff is part of it, but I also do a lot of work with things like architecture decision records. They're a really useful way of getting people together to capture some of the otherwise tacit knowledge about our architecture and our systems that might get lost if we don't have some means of trying to capture that. And even things like recording short 5-minute videos about decisions we just made about the evolution of our architecture. are really nice ways to try and capture that oral history that otherwise gets lost. And absolutely, the Scrum Master can play a role in that. And I also work with groups where there isn't necessarily a Scrum Master, like a group of architects, for example. So instilling those values is important. And you mentioned the funny looks. I can absolutely relate to that. But I find, with these things, you can't push them on people. I'm sure it's similar with your experience, but I find these tools that we're talking about are things that I've come to gradually over the last 20 years or so, and that I've discovered through a process of having a problem that I needed to solve, whether that's growing a team or building a product or meeting a customer need, and looking around the world more broadly, even outside of the field of software engineering, for ideas and influences that help to address that problem. So the goal for me is not necessarily sense making. Sense making isn't the goal. Architecture decision records are not the goal. The goal is, how do we create an organization, foster an organization that is really good at meeting the needs of all of its various stakeholders, whether that's the engineers in the organization or customers or the users of our products. And one role that we can play as architects in organizations is to help foster that sort of culture. So it's not about pushing particular tools, it's more about opening up the awareness of the organization, saying the problems out loud and agreeing on what the problems are, coming to some shared understanding of what are our challenges, what are our opportunities, and together finding tools and approaches that will address those.
So I have a lot more questions, but I think one important part, because we discussed about sense making as one side of this approach, but I think the other side of this approach, which is very important and often difficult to adopt in organizations, is making experiments. Experimenting inside of an organization, and sometimes not necessarily in order to change something, but in order to learn more about what's going on.
Right.
And the challenges I see here is not necessarily that we don't understand, or the people that I talk to don't understand what an experiment is, but it's more difficult to actually put in practice some these experiments. Do you have any methods or any ideas around managing experiments?
I do. So this is something I do quite a lot and have for a while. And again, the foundation for how I approach experiments comes from my work with sense making and complex adaptive systems, and the work of people like Dave Snowden and Tony Quidlin and the folks at Cognitive Edge and other people that I've learned from over the years with this. So what I've done is try and tailor this to an approach that works for me in software engineering organizations. So there's a couple of, I hesitate to call them rules, but sort of guiding principles that I find work well for being successful with experiments in software organizations. And in no particular order, the first one that I always try and emphasize is a distinction between designing an experiment and executing the experiment. And that process of designing the experiment is where we think about, well, what is our hypothesis for what's going to happen if we try this thing out? If we already know the answer, or if we're trying to design an experiment to achieve a very exact specific outcome, that's not an experiment. So first of all, that's an action plan, and that doesn't mean it's not valid. Call it an action plan and just go do it. That's absolutely fine. There is I suppose an inherent quality of an experiment that we don't know exactly what the outcome is going to be. You hit on the key point a moment ago. We're trying to acquire knowledge, and that knowledge is going to be relative to where we are now and what we're trying to achieve. So whether it's a technical strategy or a business strategy, we are in a certain place in the world right now, and there's a certain place we need to be, whether that's growing our user base or improving the performance of our architecture, or incorporating a new deep learning model into our system, or whatever the thing is. There's some uncertainty around exactly how we're going to do it. So when we're dealing with experiments, we're in that complex, unordered space that I talked about earlier, where there isn't an exact path from where we are to where we need to go. So recognizing all of that can often be an important conversation to have when we're talking about being successful with experiments. The second thing is to design experiments that are at your level of influence, or maybe just influencing one level up or one level down in an organization. And I don't mean that to sound necessarily hierarchical, but there is no point, if you're even a senior engineer in an organization, there is no point trying to design an experiment that's going to influence the strategy that the CEO is going to take. It's not that you can't influence that strategy, but you're going to have a more difficult time reaching that level of decision making from your position of influence. But there are lots of important and valuable things you can influence from whatever position you're at in an organization, whether it's a senior engineer or a principal engineer, or a user experience designer or a product manager. Your scope of responsibility in that organization, what is your job and all of that sort of stuff, and who are your important relationships, how do you get stuff done, and design experiments relative to that context. So what can you change without so there's two aspects to it. What can you change without going outside the boundaries of your positional authority, and where can you leverage your positional authority to stretch those boundaries? Experiments are useful for that. So I always say that we have more power and influence than we realize in organizations, regardless of what our role is. But then once we're past that, how do you actually design an experiment? Well, one is to start off with a hypothesis. How do we think things will be different? So if it's an experiment around improving the performance of our system, let's take a build system, for example. We might think of build system is just pieces of software and hardware stitched together, but it's, for me, often a complex socio-technical system. If we want to get our build times down from 2 hours to 10 minutes, there are human challenges there as well as technical challenges. So a hypothesis when we're starting out might be, if we separate unit testing from integration testing in our pipeline and have them work on different paths, we might see some sort of measurable performance improvement. So then, a completely different example might be, we want to improve the connection between our engineers and our customers or our users of our product. We want to foster closer ties, closer relationships between the people building the product and the people using the product, which can be a challenge in big organizations. So those sorts of things might be good candidates for experiments. But we should start with the hypothesis of how we want things to be different. We shouldn't just say we're going to do an experiment. Step 2 then would be to articulate, well, once we start with that hypothesis, let's identify some things that we're going to do, some things we're going to try. Step 3 would be, once we start to try those things, what are some expected signs of success? How might we see things start to improve as we roll out this experiment? But I should mention the time frame of experiments. For me, experiments should be in the order of days, maybe weeks, but not longer than that. Some things are absolutely, some things are really big and take even months or years to complete. Break those down into small experiments. So over the course of the couple of weeks life cycle of an experiment, what are some things we might see that tell us we're on the right path, we're going in the right direction? And once we see those, how do we amplify them? How do we start to encourage more of those behaviors or interactions in our organizations? The next step would be to articulate what are some of the possible signs of failure. So right up front, when we're designing our experiment, think about, how might this go wrong? How might we start to pick up some early warning indicators that we're starting to see some results we don't want from this experiment? Performance is getting worse. Our customers and engineers are drifting apart rather than coming together, or there's conflict starting to emerge. Some things like that would be absolutely things we don't want to see, or we want to see less of. So how do we counter those or dampen those things? And so there's a template that I use that captures those as steps when we're designing experiments. And it's pretty structured. And so just because we're working in a complex space with lots of unknowns and lots of uncertainty, it doesn't mean we can't take approaches that are structured, that are designed to give us information in a relatively rigorous way to help us make decisions about how we evolve our teams or our products or our organizations. And then we should always have multiple experiments running in parallel, not just one experiment. So that problem of bringing our engineers and customers closer together, we might have an experiment around collaborative planning. We might have an experiment around just getting people together for coffee. We might have an experiment around customer listening sessions or customer journeys. So there could be 6, 7, 8 experiments we'll try over the next few weeks. And the last thing I'll say about experiments is they should be related to what we need to achieve anyway. So the experimentation and experiments might be a new approach, but we're not creating extra work by experimenting. We're adopting a different approach to doing something that we need to do anyway, whether that's build a product or provide a service or build a team or grow an organization.
One thing that comes into my mind is that so I see the value of experiments definitely, but there's also a challenge in designing and in maintaining those, and there is some time invested there, no matter how little you change actually in the organization. Who are the best people to design and manage these experiments? Do you need some kind of agile leader, some kind of manager, or should it be the team? Should it be who should be involved here?
Yeah. So the short answer, and I'll expand on this a little bit, but the short answer is the people who are affected by the outcome of the experiment should be the ones to design the experiment. And it should always be a social group activity. Mm-hmm. So I should never be designing an experiment on my own for our team. We should be designing an experiment together in collaboration for our team. Mm-hmm. And certainly I shouldn't be, as an outsider, I shouldn't be designing an experiment for your team that tells you to go do this stuff. So always the people who are responsible for the outcome, whether it's the people, responsible for the product, like the engineers, the product managers, the user experience specialists, the people who are responsible for the product should design experiments related to their work. Now, I like to have experiments running at multiple levels. And again, I don't mean to sound hierarchical with this, but there are different domains of responsibility within organizations. So there are the people who are responsible for making the products and building the products and have a lot of responsibility for maybe the strategic technical direction of the organization, all of that sort of stuff. And then there are the people who are responsible for the business, who fundamentally invest in the business and decide what products we're going to build in the first place, or what, whether we're in the automotive business or the healthcare business. Those are big strategic decisions that are usually made in a different part of the organization. So I encourage experimentation at those different levels. So C teams, senior management teams, engineering directors should absolutely be experimenting all of the time on how they're evolving their organization. But the focus is on the level of the organization. Back to my point earlier, their scope of responsibility is creating an effective engineering organization, an effective product development organization, or an effective IT organization, depending on what business you're in. But that's their scope, and their experiments should focus on evolving their domain of responsibility. Similarly, for engineers, their experiments should focus on evolving their domain of responsibility. And I often use the pizza slice as a metaphor. I have diagrams that show this, but the vertical pizza slice, that there are experiments where it makes sense to have, for example, directors and engineers and product managers from different domains of responsibility working together on experiments where the outcomes affect both. But be intentional about what is the scope of responsibility of this set of experiments. Are we evolving something at the strategic level, at the tactical level, at the business strategy level, the technology strategy level? Is it a cross-cutting experiment? So but always the people who are, back to your original question, who designs the experiments, always the people who have that responsibility for the outcome of the experiment. We are designing experiments that affect how we work, is the basic principle.
One question that comes to mind when I think about this is there is a certain rigor required to design and manage these experiments. And when I think about scientific experiments, the rigor is even higher. You often need a lot of time just to figure out the hypothesis or just to formulate the hypothesis in a good way and then figure out all the necessary constraints for experiments. Here we are talking about different types of experiments. It's more empirical than scientific, let's say.
It can be, yeah. So I think there's different levels again. So if you think back to Kent Beck's original white book on extreme programming, he talked about spike tests being a form of experiment. And those, the experiment could be a matter of minutes to hours, with maybe less scientific rigor, but no less valid than other types of experiments. And the purpose still, we have some unknowns. We need some new information. We need a structured way of trying something out and bringing new knowledge into the team.
I think one of the challenges that I know of when you are designing a scientific experiment is to separate all the variables. And in complex organizations, it's almost impossible to do that from my experience. So that's what I'm referring to, is not necessarily a completely scientific experiment. It's still valid. No reason to avoid these types. They are actually very, very powerful, very useful. But they still require a certain degree of rigor when defining the hypothesis, when running them, and so on. And the question is, how can you teach people to get to this level of rigor where they can actually design their experiments and run them?
Yeah, well, a short answer might be what you approach it experimentally as well. So approach it iteratively. So I think the idea of approaching something with rigor and diligence is not new to people in our profession. There are many examples of forget about experiments in order to build a new website or build an autonomous vehicle or build a network router. There is a huge amount of discipline and diligence required in many aspects of these things. So what often is a challenge with experimentation is introducing the perspective that experimentation is a valid approach to solving our problems. Instead of just listing an action item on a project plan, we have this thing called experiment portfolio. And so introducing it gradually, it's back to my point earlier. The way I came across all of these things was in response to defined needs. I had a need to ship a product, to provide a service to customers, to build a team, to grow an organization. So I always remind people to stay focused on what is your purpose here? What is this thing that brings us together in the first place? And it's usually one of those things: building a product, building a system, providing a service, building a team, growing an organization. And we have some objectives like being a profitable organization, selling so many units of our product, making sure people still have jobs. All of those sorts of things are important and worth articulating. And sometimes they get a little lost as background noise. They're not always to the forefront of our thinking as we develop our software. But experimentation brings them right to the forefront. And a way through what you described for me is always to relate experimentation as an approach to the very concrete and real needs that people have. We're not inventing new work. We're not creating new things that you need to do. We're introducing some new ideas to try that will help you achieve what you need to achieve anyway: building a product, growing a team, all of those sorts of things. And then the template that I outlined earlier is a useful structure to help us get started with that. And some teams take that and customize it. Some just keep the same template. That's fine. like with things like A3 or other tools, it's just a template to guide your thought process. The collaboration and the work of designing the experiment and then going and executing on the experiment is the important piece, and then what you learn from that and the monitoring. So you're absolutely right. There is some additional work related to designing experiments, monitoring them. I'm wary of the word monitoring, but understanding the impact on your team, your organization, as you start to conduct experiments, just as you would with any plan, is an important aspect. But we can be iterative with these things and always relate them to the need that you're trying to address in the first place. So there's more we could say on that, and happy to go into more detail.
So when would it be a good time for designing these experiments? Is retrospective, for example, a good time when you think about them, or should it be somewhat separate from the normal ceremonies?
So I have some personal preferences, and I like doing them during retrospectives, and I also like having dedicated experiment design sessions where we can focus just on the experiments. I would always leave that as a decision or a discussion for the group. The important point is, or some important items to consider are, do we have a space, both in terms of time and physical space, where we can get the right people together to discuss the experiment and actually put some effort into designing the experiments. But probably even more fundamental for me than that is, have we identified some problem or opportunity that says to us experimentation is a good idea? It's rarely a good idea to just say, hey, let's try experiments. Why? It's a much, in my experience, a much more effective approach to say, well, we've had this problem that we haven't been able to fix for quite a while. It feels like it's taking us, for example, it feels like it's always taking us longer than it should to develop new features, or we never get as much done in a sprint as we think we should. Usually those sorts of things are pointing to factors in the system of work or the environment that are not quite right. And once people identify those observable effects, they might not be able to identify the root of the problem. There might not even be a single root of the problem. But once people have articulated those effects and how it's impacting them, that's a good opportunity to say something like, well, this problem has been around for many months now. We've tried some things, it hasn't gone away. Maybe we could try some experiments. But maybe you don't want to overload people with the theory behind complex adaptive systems unless they're interested in that sort of stuff. But you could say, hey, I've got an approach based on experimentation that might help us address this. So you're responding to a need that they've identified, and then have an experiment design session. And yeah, absolutely. If you are a team that's using sprints and retrospectives and sprint reviews and things like that, that's a fine forum. If you're using some other approach to building your products, just establish a cadence for when you write experiments, when you review them, when you understand the effects of them.
Okay, that makes a lot of sense. So I feel like we could discuss much more on this topic, but we've already discussed quite a lot. And before we move to the closing part of our conversation, I'd like to ask you about AI and how AI influences software engineering. Because it feels to me like when you're trying to include AI and machine learning into a engineering process, it changes the way you build, because it's a different kind of beast to tackle, right?
Right.
So I know you have experiences in this area, so I'm curious, what changes in software engineering when you introduce AI?
Yeah. So yeah, there's a few things that are sort of fundamental. I mean, one is the approach of, we're used to writing programs where we specify the instructions and we work towards some expected output. With AI, especially in things like deep learning systems, we're often starting with data. So we're often starting with the results rather than trying to generate the results of previous of previous things that have happened. It could be, for example, data that generates or data that identifies obstacles on a road, or that identifies dogs in photographs, or data that approves people for bank loans, or identifies spam in email. But we're starting with lots of example data in those cases, and then we're trying to train a model that will not just work for that existing data, but will work on future data as well. So it's a different sort of approach from that perspective. So another thing that AI throws into the fore of software engineering is the whole question of ethics and policy. And I think we've always had certainly an obligation and a responsibility for the systems that we build as software engineers, and should have. A very, I suppose, public cases over the last 5 or 10 years where AI systems contain some serious biases that disadvantage people. Now, in building any system, any software system, we should always be asking ourselves who could be disadvantaged by this system and how might that happen. But with AI systems, when we go through that training process, for example, so there's some famous image recognition models that don't recognize people of color because they were trained on large data sets that consisted largely of white males. So there's an inherent systemic bias in how those models were trained, how that data was captured, all of that sort of stuff. So because of the potential reach of AI systems and the potential for harming other people through disenfranchisement or through other means, we have a huge responsibility as software engineers to understand that we're not just plugging together pieces of technology. We're developing systems that have an impact on society and on people's lives. And we could talk about how things like the Facebook algorithms or the YouTube algorithms work, and how AI is playing a role in that. There's also, sometimes it's easy to say AI has a bias problem, when really what I like to do is step back and say, well, as people, we are the ones who are training these systems and developing these models and gathering the training data sets that are provided as input and validating that they're working as we expect. So, far too often that bias exists within us, but we're not acknowledging that. It's easy to say there's a problem with the AI system. Really, there's a problem with our socio-technical system and how we're approaching building software systems. So back to your question, ACM and IEEE, for example, have had a framework of technical ethics for quite a long time, which is a very useful guide for us as software engineers. And extending that in this new era of broad-reaching artificial intelligence-based applications, I think, is critical. But also for us building these systems, it's not enough just to have an ethics framework. We need to be actively using it as a guide, informing the product decisions that we're making in these systems, and that's I suppose a huge responsibility that we need to feel.
I also feel as an outsider or a relative outsider to this problem that besides these things that you named, there are also some practical problems in terms of development process. One of them I can think about is estimation. I am not sure you can estimate. Well, it's hard to estimate software development, but it's probably much harder
Yeah.
to estimate developing a machine learning algorithm for something, right? Because it depends on a lot of factors. It's a lot of trial and error. It's a lot of mixing and matching algorithms.
Yeah.
Right?
So this goes to in some ways to our discussion on experimentation earlier on, and you're absolutely right. There is some inherent uncertainty. So in terms of the ordered system space versus unordered system space, with a lot of AI systems, absolutely we're very much in that unordered system space, where things are not always as predictable as they are in other areas. So there's some metrics that are important, like accuracy metrics of our model and so on. When we apply our model to new data that it hasn't seen before, whether that's new images with dogs, or deploy it in a car on a new road that the car hasn't driven on before, will our model behave as we expect it to? So in those cases, we want to minimize the loss as much as possible. But you're absolutely right. Sometimes it takes a lot of experimentation. So there's a whole area that we could talk about around ML ops, and what we want to do is, as much as possible, establish effective feedback loops between the point where we're defining a problem space and training a model, validating that model, deploying that model into a full software engineering system, and having it operate in a real environment, getting some data in the actual environment and feeding that back so we understand the performance of the model in real world settings, while at the same time over here we're still tuning and tweaking our model and trying to improve it in a more laboratory setting. What we want to do is try and shorten that feedback loop between model training and real world deployment as much as possible. And that's one of the areas where we know a lot about from the software engineering perspective. We know a lot about deploying systems in real world environments and getting feedback on how those systems are performing. What we're doing now is taking that back into a situation where models are being continually retrained based on the real world data that we're collecting, and we can update those models. There's obviously policies around how we update models and when we update models, but that feedback cycle for me is critically important, and paying attention to that.
And I also think that one of the challenges is that these systems can evolve in unpredictable ways sometimes, right?
Yeah.
So it is theoretically possible that your system will lead to a catastrophic problem in a real environment, and so you need to plan for that in some way. And then debugging these kind of problems is much harder than debugging. Already software is hard to debug, but debugging AI, I think it's much harder, right?
Well, absolutely. And one of the areas in AI that's a very active area of research and practice is around the idea of explainability. So with AI systems, we can often see, okay, here's the data that we use to train the model, and here's the data we use to validate the model, and here's how it's behaving. But in some AI systems, it's hard to impossible to understand the process that those systems use to make decisions. So there is a lot of work around explainability of AI systems, absolutely. But a lot of the challenges you describe, I mean, we have those challenges anyway in large, complex software systems without AI. Adding AI systems into the mix, you're right, creates some interesting challenges, absolutely.
And in terms of architecture, do you have... So I'm thinking about a few things. One is splitting into different modules, which is a common part of architecture. But I can imagine you can apply this for models as well. So you could have a big model, or you could have smaller AI models. So that might be an architectural decision. And then the degree of accuracy can also become an architecture relevant constraint, right? That you need to
right.
to look
Yeah.
at.
No, absolutely, absolutely. And so I work a lot with an area called sensor fusion, which is, as the name implies, it's about fusing information from different sensors. So, from an AI perspective, we might have camera sensors, which is taking in visual data. We might have lidar data, which is taking in light data, radar, and we might have other sensors as well. And each one of those, from an AI perspective, would have different models and different ways of thing, and we'd have some sort of central system for fusing together the data from those different sensors and making decisions based on that. But separation of concerns, absolutely, it's still an important fundamental architecture principle. You don't want your camera, sensor code, and models to be overly dependent or even know about the existence of necessarily your LiDAR models or your radar models or your other sensor models. You might have audio data that's coming in as part of the mix as well. But all of those are, we think about it almost from a microservices perspective. We have audio services, video services, LiDAR services, radar services, maybe temperature gauging services, and there are other orchestrating services then that fuse information from these multiple different sources in order to make decisions, where a decision might be slow down, go faster, turn left, turn right. But ultimately, those decisions are based on data gathered using multiple different models, which might have different life cycles, but are deployed in a single vehicle or a single autonomous entity.
Okay, so this has all been very, very interesting, and I think it's a good time to mention that you will have a keynote at ITECAN conference on architecting systems for an AI native future, and this is I can't wait for that. So we could spend a lot more time discussing. I'm sure there are many, many interesting ideas, but we are already we have already discussed quite a lot. So we usually end these shows by going through 6 questions. None of them is mandatory. They are all a surprise for my guests.
Okay.
But I like them because they are a way of connecting and learning more about you on different, let's say, on a more personal level than on the technical side.
Okay.
The first book is the first question. What book did you like and would recommend? It doesn't have to be technical. It can be technical, of course.
Okay. So let's see. One that I'm reading right now is a book by Sean Carroll. It's called Something Deeply Hidden. So Sean Carroll is a physicist, and he works in the area of quantum physics, and it's an area that I find fascinating, and it's a really, really interesting. But he also writes in a way that's very accessible and very enjoyable. So I'm enjoying that at the moment.
Yeah, this is a very fascinating field, and very weird field as well. Okay. What category of books you don't read too much and why?
Ooh, do I not read too much? I probably don't read enough nonfiction, actually. I'm just thinking about throughout the last year or so, I haven't been reading enough nonfiction. Or sorry, fiction, excuse me. Probably don't, the other way around. All of what I've been reading for the last year or so has been largely nonfiction. Not necessarily, so a lot of like books on software and architecture, but also other things like science and history and various other things. I find all of that really fascinating. yeah, I love there's a couple of authors I really like in the fiction world. I love Stephen Pressfield's work. I love George or Martin's work, and I'm eagerly waiting for the next Game of Thrones book. But so not enough fiction the last year or so. Why? That's probably just. That's a good question. I'm going to reflect on that, but time is obviously a constraint, and I've been caught up in building stuff, and so a lot of the stuff that I've been reading has been in relation to in relation to that, which, because I enjoy it, doesn't feel like a chore, but at the same time I miss some of the fiction stuff.
Okay. What topic do you think is under discussed in the industry or communities?
Under discussed. Just one, or
it can be more. These are fairly open questions.
Yeah. So in no particular order, maybe just because we were talking about it a few moments ago, but bias is probably one that's under discussed. We all have biases. We have ones that we might even be aware of. We certainly have unconscious biases that we're not aware of. So the effects of acknowledging those biases and understanding their effects on how we work together, how we interact, how we collaborate, I think is often under discussed. And then how those biases, like we were talking about earlier, how those biases influence the products and the systems that we're building. I think that is under discussed. I think, well, not to get too philosophical about it, but I think the world in general has a hard time discussing difficult topics, and very often decides to not discuss difficult topics, and in our industry I think is no exception. So I cite biases as one example, with maybe that general topic of how do we have productive, healthy discussions around difficult topics being another.
And the next question, what topic do you think is discussed too much in the industry or community?
Discuss too much. Yeah, nothing particularly comes to mind. And partly I'll say this partly because I feel like it would be a value judgment for me to say something is discussed too much. Personally, I would have a reaction to somebody telling me that I'm talking about something too much. I would not like to say to somebody else, you're talking about topic X too much. Because if you're talking about it, it's important. It's important to you. It's going to be important to other people. And just because something, there's an old saying that I'm going to paraphrase badly, but just because something has been said already doesn't mean everybody was listening. So there is a need to revisit topics more than once in our industry. And if somebody is talking about it, whatever the topic is, it's important to them. And I like to respect and acknowledge that. And I'm happy to engage in a discussion on just about anything, even if it's something I've talked about 10 times or 1,000 times. I have no issue with that. But there, I think we need to remember there. So I've been in this industry for a little over 20 years. There are people who have been in this industry a lot longer than I have. There are people who are just entering this industry and trying to figure out what it is. I wouldn't like to place limits on what we can talk about or how often we can talk about it. Let's create without sounding too fluffy or altruistic. Let's create and foster an environment where it's okay to talk about just about anything.
Okay. What would be your ultimate career achievement?
Well, so one of the reasons that I've gotten into AI and self-driving car technology over the last few years is the potential for impact on people and the planet. So one of the statistics that spoke to me a few years ago So Ralph Nader, US politician, was back in the 60s. He was responsible for writing the legislation that forced automobile companies to install seatbelts in their cars. Before that, seatbelts were optional. You didn't have to include seatbelts. And at the time, 96% of road-related deaths were due to manufacturer error or some design flaw in the vehicle. In 2021, 96% of deaths on the road and fatalities and injuries are driver related, either lack of attention or drink driving, drug driving, poor quality driving, lots of reasons, but 96% is related to the person. And that to me is a scary statistic. But one of the things that excites me about the technology in self-driving cars and AI is the ability to have an impact on those numbers. And the other side of that is the environmental side. Self-driving cars are very much tied in with connected autonomous electric vehicles, so the electrification aspect should have a reduction on the negative impact on our planet, all of that sort of stuff. So yeah, if I can spend the next 20 years or whatever working on systems that can save lives and improve the planet, I'll be very happy. But also doing that with people that I enjoy working with and having an impact on people's lives as well. So one of the things I enjoy is learning from people, but also helping other people grow in their careers, all that sort of stuff. So combination of all of those things.
All right, and to close this list of questions, the last one, what advice would you give to a younger version of yourself?
Let's see, worry less about what people think.
That's a good one, I think, always. Okay, this has been amazing, Ken. Is there anything else that you'd like to tell our audience that we haven't discussed, that we haven't touched upon?
No, like you said, lots of things we could talk about. It's been great chatting with you, Alex, and thank you very much.
Where can people find you?
So I suppose my couple of places, my website, kenpower.io, GitHub, LinkedIn, Twitter, at the Mozaic Works conference next week, various other places. I'll be talking at the XP conference as well in a few weeks' time. But generally my website and LinkedIn are good entry points for what I'm up to at the moment.
Excellent. Thank you, Ken. This has been an absolute blast, very interesting conversation, and I enjoyed this. All these ideas around complex adaptive systems. I think there's much more to be done there until they become part of the knowledge and the day-to-day practice in software teams. That would
absolutely
be a good ideal to have. I'd like to thank you all for watching. We have touched today on a number of topics. If you're interested in some related topics, we have on the channel a conversation with Dr. Roger Kneebone. We are talking about similarities and differences with the medical domain. So that's actually on the channel. You can check this out. Rebecca Worsbrook, also mentioned by Ken. You can find the conversation with her in the list as well. We have to pay our dues to the YouTube algorithm, so please like, share, subscribe, comment, tell other people about this channel. We'll be coming back with more interesting conversations, but until next time, remember to think, design, and work smart.